Hello, everyone. Welcome to Storing Your Data in the Cloud, Doing It Right. Today, I'm going to introduce you to object storage, the right way to store data in the cloud. I'm Orit Wasserman. I'm a Senior Principal Software Engineer at Red Hat. I've been developing software for many, many years already. I'm almost half of my career in open source. I love low-level programming and especially storage, and been working on different storage systems distributed for quite a while. In the last few years, I'm focusing on Ceph, which is a software-defined storage, completely open source, and of course, it provides also object storage, also block and file. And today, I'm Openshift Data Foundation architect at Red Hat. Openshift Data Foundation provides persistent data services for containers application running in Openshift, which is Red Hat platform as a service infrastructure for the hybrid cloud based on Kubernetes. And I'm from Israel, if anyone interested, working from home even before COVID. So today I want to introduce you to object storage. I want to tell you what's special about it and why it's such a good fit to the cloud. Then we'll go a very cool, unique feature it has that make it even more perfect for the cloud. And as we're talking about cloud, we also have to have a section about security and privacy. So storage is a very important infrastructure, been around for quite a while. This is actually the evolution. And now in today's cloud era, it's transformed even more. And usually when we talked about storage, we would divide it to block storage or file system storage. But now today, we also have a new kind of storage called object storage. So why do we need this first type? So basically, what happened is that we create so much data, zetascale data, actually. It's not, as you say, it's like 1,300 exabyte, which is actually zettabyte, and it grows exponentially, which means that we need different kind of storage system to store the data that can be very, very scalable and also be cost effective because it's also quite expensive to store so much data. And block storage and file system have inherent limitation that make it harder. So that's why there came the object storage. So what is object storage? It's first of all, it's a flat namespace. We have buckets. Bucket contain objects. We reference object by name, so it's bucket. So if you tell bucket, you want to reference the object, you tell this bucket and that other object name. But a bucket cannot contain another bucket. Unlike with file system, the directories can have other directories inside. We are talking about flat namespace. This limitation helps with reducing the cost of the storage and make the management much more easier for the storage. The second difference from files is that objects are immutable. What do you mean immutable? I don't mean that objects cannot change and be updated, but the way we update them is as one entity. You cannot update a part of the object, you overwrite it completely. You can, of course, read whatever part of the object, range read, whatever you want, but when you write an object, it's always the full object. And because it's much easier to manage the storage with object storage, we can add very rich metadata to the object and better access control, but also user metadata. So I'm, as a user of object storage, can store my metadata on the object, and we can see example where it can help us. It can help us with analytics, with search of object, and so on. Object storage has been around quite a while. People don't know, but from the middle of the 90s, it's quite a while. But it didn't break out. It was like a niche EMC had Centera, which provided, they call it content addressable storage, but that was it. What changed and made object storage so popular is the cloud. In 2006, AWS announced their cloud service, EC2, Elastic Compute Cloud, and a storage service that comes with it called S3, Simple Storage Service, and I really like the name. And S3 is object storage. Object storage with one addition that is very important. All the access to the storage, all the management is done with RESTful API. When I refer to RESTful API, it means the API is always by using an HTTP request, which is perfect for the cloud, because in cloud, we always have lots of service all around. Usually all our access are remote, and HTTP makes it easier. It's quite easy to use HTTP to access a remote server or remote storage. You don't need to do the firewalls are open, everything is standard networks, and much easier than the storage protocols. And today, object storage is dominating the cloud. We have, of course, AWS S3, which is huge. Every big cloud vendor has its own object storage, Google Cloud Storage, for example, Azure Blob Storage, and so on. And on-premise, we have Ceph that also provide S3-compatible object storage. And I noticed about DigitalOcean because DigitalOcean are using Ceph to provide cloud object storage as well. So let's look at example of uses of object storage. So the classical, as we say, is photos. So if you think about photos are in nature immutable because of the format of photos. Even if we just edit the photo, let's say rotate, we have to write the photo as one unit. You never write parts of the photo. So object storage is classical for photos. This is Flickr. I don't know what's going on with Flickr. It used to be Yahoo, but I don't know. I always use Flickr because they use Ceph as well. So here in Flickr, we have albums. Album is a bucket. And of course, its photo is a different object. So our first problem is uploading the photos to the cloud. Photos are growing actually bigger. We have better cameras on the phone. So when we upload the photo in the cloud, it's very annoying if we have some network error or some other problem and we need to upload them again. And also, it's not always photos. Sometimes we want a video. Those are even bigger. So we need a different way to upload the photos, the object, to the cloud. And object storage has what we call multi-part upload to solve the problem. So multi-part upload, with the name, we take the big object and we cut it into parts and we upload each part separately. It's a transaction-based protocol. First of all, you have an init command. You go to the object storage, tell him, I want to upload this object. You give it the name. You can tell him how many parts and part size, but you don't have to. And the object storage will return an upload ID. You need to use it or keep it. Then we upload each part separately and with the correct upload ID. And when we are done, we send the complete command, and only then the object will be created on the object storage and visible there. So now, when I upload a big object, first of all, in case I have a network problem, all the parts that were already successfully uploaded will be there. Then I also can parallelize the upload, getting much better network throughput, much shorter time to upload. I can pause and resume object. So for example, for my phone, I only upload photos when I'm in Wi-Fi area. So if I go out of the Wi-Fi area, the upload will pause. And when I go back, it will continue from the last part that I still didn't upload. You can upload an object you don't know the final size, for example, when you stream video, and you can use it as a transaction instead of what we use with file system rename. But there are some pitfalls from using multi-part upload. First of all, you need to understand the performance. Instead of one request, we have 3. So if the object is small, you wanna make sure that you actually don't use multiple upload because you can get up to 3 times slower throughput. And also, if you use regular upload, you should know that the object size is limited to 5 giga. So always for object larger than 5 giga, you should use multiple upload, which is limited with 5 tera. Luckily, when we use S3, we have lots of frameworks and SDKs that can handle all those for us, and you just need to make sure that the defaults are set correctly and the threshold to using multiple upload is correct. Another problem we have is what happens if I never complete the upload. I'm storing the parts in the storage, so I'm using capacity and actually paying for it, but it's a waste. We call those orphaned uploads, and those needs to be cleared up. You can do it manually, and later in the presentation, I'm going to present you how you can do it automatically. Let's look another example of documents. So first, it seems that documents are not a good fit for object storage because documents are actually very immutable. You change them a lot in every part. But as they are relatively not large and the updates are infrequent, human frequency is low compared to computers, they actually are a good fit. And what object storage adds to documents, which is a very important feature, and as you can see here, I can keep version from the document. So if I did a mistake and I want to invert back, I can go to the storage and get an older version. So what happens if I don't specify which version I want to read? I'll always read with the current version, the latest, but I can specify the version ID and get an old version. If I want to, I can revert to it. So basically, versioning is a bucket feature. You enable it per bucket, and then you'll get, every time you overwrite an object, it won't be, the old data won't be deleted, but the new version is added. As you can see, one problem here is that it uses lots of space. So if I have a document that is 5 mega usually, if I have 10 versions of it, I'm using 50 mega. That's a lot. So what we need to do to remember when we use versioning is to delete the old version that I no longer need. So we free up space. Sadly, I don't remember to do anything. But here, the object storage help us. You can see this is an example from Drive, Google Drive. The older version are only kept for 30 days. The object storage will delete them for us. This is, I think, with the best feature object storage has, and it's called lifecycle. Lifecycle, you can configure a rule on the object that the object storage, and when the condition met, the object storage will execute the rule. You have 2 types of transitions. One is expiration, deleting the data, and one is tiering, moving the object. So for example, with expiration, I can tell the storage, I want to delete all the versions that are not current version, but are older than 30 days. This is one kind of rule. The other kind of rule, I can say, I want to delete all the multi-part upload that haven't completed for a week, for 7 days. This will clean all the failed multi-part upload I had and clean the space automatically without any need of my involvement. And usually tiering is used for archiving. I can say any object that wasn't read for the last year should be moved to the archive as it's not used. It's a very cool feature. I think it's very useful. Another example, I said we are a flat namespace, but you can actually have a much complex hierarchy. For example, here you have folder 1 containing folder 2 that contain folder 3. You can do it in object storage. This is with what is called in S3 prefix. Prefix is basically a key, a metadata key that you can add to an object. So for example, objects that are in folder 1 will have prefix / folder 1. Object in folder 2 will have a prefix / folder 1 / folder 2, and so on. And when we do a listing of a bucket with a prefix, you'll get only the object that specifies this prefix. So if I want to see only the object in folder 2, I will give that prefix to the listing and get them. As we are in the cloud, it's very important to make sure your data is secure and to keep it in private. I've sadly seen many misconfiguration that made the data public. So first of all, use HTTP unless it's your own private network or you have VPN. Sadly, it's not default. I wish they would do that, but make sure HTTPS. Transport is encrypted. Next, the storage itself always encrypts the data when it gets the data. This is server-side encryption, but that's not good for your privacy. Object storage has client-side encryption, meaning the data is already encrypted in the SDK, basically, and even before it gets to the network, actually. And when the storage gets it, it's already encrypted. This way, we, the storage provider, can read your data. You have two types of keys. You can provide your keys or use a key management system. Another thing, we have access control for bucket. One of the default, but it's not default, one of the options is public bucket. Please don't use public buckets. There are lots of leaks every few months of public buckets. Today, AWS actually can warn you if you have such buckets. So we have lots of granularity of access control to bucket and object. Sadly, I don't have time to go over them. Please use them and try to use the most limited access you can. And we have relative new, we have bucket and user policy to allow you much better granularity. For example, you can share bucket between user. You can give a read only for anonymous user. You can restrict for specific IP or MAC address. So presenting you today object storage. It's designed for the scale of the cloud and its unique features make it perfect to the cloud, and it can help you to develop much better application for the cloud. But to use this feature, please use the storage, the APIs, and not use it as a file system, as that won't allow you to use features like versioning or lifecycle and so on. We are in the cloud. Make sure the data is safe and is private. And if you use a private cloud, please use Safe Redis Gateway for your object storage. Feel free to ping me for question in the, I assume will be the conference chat, not this chat, or Slack. Thank you.